also roll a die. And I will say B is that the die lands on 6. Okay, so the probability of B is equal to what? 1 out of 6, or 0.1667. So far, so good? Okay, so if I flip a coin and roll a die, what is the probability that the coin lands heads and the die lands on 6? What is the probability of that happening? Okay, do we have an answer?
Yeah.
Yeah, what is it?
0.0335.
Okay, 0.08333. Okay, so this is going to be the probability that the coin lands on heads and the die is lands number 6. Okay, so this would equal the probability that the coin lands heads times the probability that the die lands on 6. So the probability that the coin lands heads is 1 out of 2. It lands on heads half the time. The die lands on 6 1/6 of the time. So the overall probability is 1/2 times 1/6, or 1 out of 12. Okay, and that makes sense, right? 1/6 of the time, the coin die is going to land on the number 6. When you flip the coin, half the time it lands on heads. So what's the probability that if you do both of those things, that you get heads and it lands on 6? 1/12 of the time. And 1/12 is equal to 0.08333. Okay, we could have just done this in fractions as well. 0.5 times 0.16667. Okay. And yes, because of rounding, it might not be 0.83333, but that's what it is. How does that feel? Good? Okay. If, let's say I roll a die 3 times in a row. Or let's start off with twice in a row. Roll a die 2 times, 2 times.
Is this an example?
This is a new example. Roll a die 2 times. Okay? For each roll, the probability that it lands on 6 is equal to 1 out of 6. So if I roll it twice, what is the probability that it lands on 6 both times? Do we have an answer? You can leave it in fraction form. 1 out of 36. Because for the first roll, the probability that it lands on 6 is 1 out of 6. And then for the second roll, it must also land on 6. So we multiply those two things together. Okay? Because in order to get for it to land on 6 both times, it has to land on 6 the first time, and it has to land on 6 the second time. And each roll is independent, right? The outcome of the first roll has no influence on the outcome of the second roll. So they are independent. I can multiply the things together. 1/6 times 1/6 is 1 out of 36. Is that okay? Okay, what if we roll the die twice? So we roll the die 2 times. What is the probability that neither roll lands on 6? Okay, so that means it did not land on 6 the first time, and it did not land on 6 the second time. Don't try to think about it. Okay, what's our answer? You can leave it in fraction form or give me a decimal.
25 over 36.
Yeah, the answer is 25 over 36. What's the probability that you roll the die and it's not a 6 on the first roll? 5 out of 6. And it has to happen again. 5 out of 6. We get 25 out of 36. In decimal form, we have 0.6944. 6944444. Is this okay so far? Alright. Let's okay. Let's say there's a wheel. Alright, at a carnival. And over here you lose, but if you get it in the piece of pie, you win. Okay? And so let's say the wheel is set up so that the probability of winning is equal to 0.2. And that means the probability of losing is what? 0.8. Good. So you spin the wheel. Alright, so let's say you spin the wheel 3 times. Ask a few questions. What is the probability you lose all 3 times? What is the probability you lose the first spin, lose the second spin, and win the third spin? What probability you win one time. Exactly one time. Out of 3. No.
Isn't that the same as the
No. One time out. With these things. Okay, I've written out 4 questions. You should be able to answer the first 2, and the last 2 I will go over with you guys. So I'll give you a couple minutes, just try the first 2 questions, and then we'll go over all of the questions together. All right. Are we going to go over the answers, or yes? Okay, what do we have here? What's the probability that you lose all 3 times?
2.45.
Okay, I'm getting 0.512. That's my answer. Okay. So that means, what is the sequence of things that has to happen? You're playing the game 3 times. So the first time you play, what happens? You lose. The second time you play, lose, and the third time you play, lose, right? And these are all independent events. What happened before has no influence on what happens in the future. So the probability of you losing the first game, what is this? 0.8 times 0.8 times 0.8. When you do that, you get 0.512. Okay. What about this one over here? The answer is 0.128. Do we get that? So the first game you have to lose, the second game you lose, and the third game you win. And so we have 0.8 times 0.8 times 0.2, and we get 0.128. Is that okay for the first and the second examples? Okay, the third example is a little tricky, all right? So the first one, and so this example and this example, they sound similar, but they're all a little different. This one says, what is the probability you lose the first spin, lose the second spin, and win the third spin? So we're given an exact sequence of events. Here it says, what's the probability you win exactly one time out of the 3 spins? Okay? So in this situation, you still have to lose twice and win once. But we don't care if you win it on the first spin, you win it on the second spin, or win it on the third spin. Does that make sense? So this can happen in 3 ways. You can go lose, lose, win. Or you can go lose, win, lose. Or you can win, lose, lose. Is that okay? So these are the only ways you would win exactly once out of the 3 spins. Okay. We found the probability of this first one, lose, lose, win, to be equal to what? 0.128. What's the probability of lose, win, lose going to be equal to? 0.128 also, right? Because it's 0.8 times 0.82 times 0.8. It's the same numbers, just in a different order. So multiplication, the order of your numbers and multiplying doesn't matter. So we're still going to have 0.128. And here I'm also going to have 0.128. In all cases, I'm multiplying 0.8 twice times 0.2. Is that clear to everyone? Okay, so then I add all of these up and I get 0.374. I think? No. 384. 0.384. 0.128 times 0.384. So the answer, what is the probability you win exactly one time out of the 3 spins? That answer is 0.384. Is that okay?
So you weren't based off of the other question basically?
I did. Well, I mean, I could have done this, done 0.8 times 0.8 times 0.2, but we had already done that in the previous steps. I'm just using that information so we don't have to repeat myself. Okay. Yes?
Did you do the probability of winning once over the probability of losing twice? Wait, 2 times?
That would not give you
It wouldn't be the exact answer.
it would not give you the right answer. It might come out close by coincidence, but that's not that would not be valid. Okay? And this last one, it also sounds similar, but it is different. It says, what is the probability you win at least one time out of the 3 spins? Okay? So what's the difference here between this one and the other one? At least once means you can win once, twice, or 3 times. Okay. So the answer here, should this be bigger or smaller than the answer here? It should be bigger, right? Because this is, you win only once out of the 3 times, and here you can win only once, or you can win twice, or you can win 3 times. Okay? So this includes winning 1 time, 2 times, and 3 times. Okay? So there's a few ways we could do this, but I'm only going to show you one, okay? So, well, one way is I can figure out the total probability of winning 1 time. And we've actually already done that, and we found out that answer is 0.384. Then I can find the total probability of winning exactly 2 times. And it would be similar in calculation here, but it would be some work. And then I could finally calculate the probability of winning exactly 3 times. And then I would add all of those up. I'm not going to do that. What is the one outcome that I did not include that is not allowed in this situation?
Not winning.
Not winning, okay? So what is the probability that you win at least 1 time out of the 3 spins? You have to win at least once, twice, or 3 times. What's not allowed, okay, is if you lose all 3 times, or which is equal to winning 0 times. as for outcomes, if you play the game 3 times, those are the only things that could happen. You either win 0 times, you win 1 time, you win twice, or you win 3 times. Okay? When you play a game 3 times, one of those 4 things will happen. Okay. Do we know the probability of winning 0 times? Yes, and we found that to be 0.8 times 0.8 times 0.8. And we said the probability of winning 0 times is 0.512. So everything has to add up to 1, right? So everything has to add up to 1, so that means everything here plus this must add up to 1. Okay, so whatever. So not allowed is winning 0 times. So winning 0 times has a probability of 0.512. Everything has to add up to 1. So what is the number that goes here so that these things add up to 1? 0.488. Okay, basically I'm doing 1 minus 0.512. And so that would be the probability of winning at least 1 time. So this brings out an important thing to note, is that winning at least once is the complement of winning 0 times. No matter how many games you play. If you play 10 games, winning at least once is the complement of winning 0 times. You either win 0 times, or meaning you lose every time, or you've won at least 1 time. So if you can figure out the probability of winning 0 times, you can get the probability of winning at least once by taking the complement. Is that okay? Yes?
So you just subtract.
Yeah, so I just did 1 minus 0.512, and I got 0.488. So the probability of winning at least 1 time is 0.488. Okay. Is this okay? We have a question? No. All right. You will have some exercises in your homework. I would pay attention to these last few examples that I did here as you study for your quiz next week. Okay, so we'll see you guys in a week.